Hey guys, okay, this is probably one of our last sections that we'll be covering. We might get to 3.4 when I get back on here after having the baby in a few weeks. So 3.3, it's just putting everything together. So before we've done ax squared and we graphed ax squared plus c, but now we're adding in that bx. So this might have to be in 2 video segments. It might take a little bit longer. But it says graphing f of x equals ax squared plus bx plus c. This is it over here, sort of. It's one of them. The graph opens up when a is greater than 0. So when this a up here is positive, it opens up. And it opens down when a is less than 0, or when a is negative. Because remember, negatives represent reflections. Okay, it says the y-intercept is c. So whatever this c value is, that's where it crosses the y-axis. So if it's plus 2 at the end, your y-intercept will be at 2. If it's minus 7 at the end, it'll be at negative 7. The x-coordinate of the vertex, oops, I don't know what I just did. The x-coordinate of the vertex is negative b over 2a still. We know this. And then it says the axis of symmetry is the x equals negative b over 2a. And we know this already as well. So example 1, find the axis of symmetry in the vertex of the graph of the function. So step 1, we always do our axis of symmetry first. So x equals negative b over 2a. Remember, negative b, so this is our b value. So we have negative 8 over 2 times 2, which gives us negative 8 over 4, which gives us negative 2, and that's our axis of symmetry. So that's part A. To find part B, which is the vertex, we just, and I wrote a note over here, plug x equals whatever into the function to find the y value. So we take this negative 2 and plug it in for f of x. So we have, those are our a, b, and c values. I forgot to show you that. We plug negative 2 in for our function, and we get 2 times, times 4 plus negative 16 minus 1, which is 8 minus 16 minus 1, which is negative 9. So your vertex is this ordered pair, negative 2, negative 9. And that's all you have to do for this one. And I think you should hopefully remember this from before we left school, but this is an important section to know how to do this. Alright, so numbers 1 through 2, I want you to, or 1 through 3, I want you to try those on your own. So pause the video and try them. Okay, if you tried them, our axis of symmetry, we have negative b over 2a, and that's going to end up giving us 1/3. Okay? So we want to plug that 1/3 in for f of x. So we have 3 times 1/3 squared minus 2 times 1/3. 1/3 squared, remember you square the 1, square the 3, so it gives us 1/9. So we have 3 times 1/9, which is 3/9, minus 2/3. And you can do this in your calculator. You can do it by hand, by reducing this fraction, however you want to do it. And then is negative 1/3. Okay. And then we plug the values in for our x and y, and we get 1/3, negative 1/3. All right, number 2. If you tried that one, okay, so number 2, your axis of symmetry, you plug in negative 6 over 2 times 1, which gives us negative 3. To find your vertex, we plug that into our function, and you get negative 4. So make sure you're checking your math on that. So your vertex is negative 3, negative 4. Last one. We're going to have fractions in this one, and it's okay. You should have gotten a decimal. So your axis of symmetry is negative 7 over 2 times negative 1/2. And that will give you negative 7 over negative 1. So 2 times negative 1/2 is just negative 1. And negative over a negative is positive. So we plug in 7. That's going to give us negative 1/2 times 7 squared plus 7 times 7 minus 4. Remember, 7 squared is 49. this is where your decimal comes in, because negative 1/2 times 49 gives you negative 24.5. And so then you just add those up and you get positive 20.5. So your vertex is 720.5. All right, example 2, we're going to actually graph these and state the domain and range. So you may remember, step 1 is to find the axis of symmetry, which we've done before. And I didn't cover this up because I want to be able to point things as I show you, but finding the axis of symmetry, negative b over 2a. So you have 6 over 2 times 3. Well, negative 6 is 6 over 2 times 3, which is 1. So we use that. That's our axis of symmetry. So this dotted line is at x equals 1. So put our dotted line there. Now we want to find and plot the vertex. So we take 1 and we plug it into our function. And that gives us 2. So our vertex is at 1, 2. So this is our vertex right here. Okay, step 3, use the y-intercept to find 2 more points. Remember from the first page we said the y-intercept was c, so our y-intercept is 5. So you put a point here at 5. And this is like when we thought back to before we were out of school. C equals 5. Oops, I uncovered the wrong thing. So c equals 5, so your y-intercept is at 0, 5. We've plotted that point. Our axis of symmetry is at 1, so if we go over 1 and then go over 1 more, that's going to give us our second point, and it's going to be at 2, 5. Alright, so domain and range, we'll just connect those points. Domain is always all real numbers, or negative infinity to positive infinity, however you want to write that. The range is the y values, so we use the y values, or the y value of our vertex. And I have it written a little differently on this set of notes, but hopefully you remember, let go of it, Campbell. Hopefully you remember that we do like y is greater than or equal to or less than or equal to that y value. So you can write it like this, from 2 to infinity, or you can say that y is greater than or equal to 2, which is how we've written it before. Okay, so try these on your own. Pause the video, try them on your own for a second. What you should have gotten for 4, if you pause the video, was your axis of symmetry is at negative 1. So if we look here, this dotted line is at negative 1. Okay, you plug that in for our function, and we end up getting negative 1 again. So your vertex is at negative 1, which is that point there. Now you have to decide what your y-intercept is going to be. And in this case, it's 1. That's our c value, so you put that here. From here, we go over 1 to the axis of symmetry, so then we have to go over 1 more, and that'll be our second point, which is at negative 2, 1. 5 and 6 are the same way, and I don't think you should get fractions on any of those. So your axis of symmetry is at 4, and I labeled mine by 2s, or numbered mine by 2s on this one. Then plug that 4 in, and you're going to get negative 9. So at 4, negative 9, I'll put that right there. And then your c value is 7, so here's our y-intercept at 7. We count over 2, 4 to the axis of symmetry, and then 2, 4 more to get that other point. And that other point is at 8, 7. Number 6, your axis of symmetry is at negative 1. So that is right here. Plug that into your function, and you get 3. So our vertex is at negative 1, 3. Okay, our y-intercept this time is at negative 2. So that's right here. We go over 1 to the axis of symmetry, and then over 1 more, and that gives us that third point at negative 2, negative 2. I don't know why I don't have that written there. But that's what it should look like. Now I need to talk about the domain and range of these. And again, I have the range written differently than when I showed you before. So either way is fine with me. Our domain is all real numbers, always. So we can go ahead and write that for everything. Now our range. This one, it opens up So these numbers are greater than our y value. So we'll say that y is greater than or equal to this -1. We can write it like this. So you can write y is greater than or equal to -1. This one opens up again. So y is greater than or equal to this y value right there, which is -9. Y is greater than or equal to -9. And then this one opens down. So all of these numbers are less than that y value. So y is less than or equal to this y value right here, which is at 3. So you can write like this, or y is less than or equal to 3. All right. So the next page says that the y-coordinate of the vertex of the graph is is the maximum value when a is less than 0. So when it opens down, the y-coordinate is going to be less than 0, so it'll be negative. And that'll be your max. Or it's going to be a min value when a is greater than 0. So you can see these right here. If it opens down, it has a max. If it opens up, it has a min. Example 3, tell whether the function has a min or a max, and then find the value. So the first thing we want to look at is this a value. It's a -4. Okay, so a is less than 0, which means it opens down, making it have a max. So it's less than 0, so it opens down, and it makes it have a max. Now to find that max, we just do the same thing that we have been doing. We'll find the axis of symmetry. So -b/2a, we get -3. Plug that into our function, we get our y value to be 17. So your max is the ordered pair of -3, 17. And we're not going to do example 4. No word problems while we're not face to face. Okay, last part, MP3 and 4. I want you to pause this and try it on your own. I have about 3 minutes to get through this with you before the video cuts off, and I think we can do it. So number 7, same thing. A is now greater than 0 because it's 8. So A is greater than 0, which means it opens up, making it have a min value. And we're going to find that vertex. So we find the axis of symmetry first. -b/2a gives us 1/2. Okay, so we plug in 1/2 to our function. We should get 4. So don't be afraid of these fractions because a lot of the times they're just going to equal a whole number. So your minimum value is 1/2, 4. And the last one, our a value here is -1/4. So a is less than 0, which makes it open down. Remember, when they open down, they have a max. So let's find our x value. -b/2a gives us 6. Plug in 6 to your function. We get 10. So our max value is at 610. Okay, we're not doing that one. So this is it for this section. And like I said, this might be the last section that we get to. Or we might be able to get to 3.4 when I return online. So make sure you're checking your agendas and everything like that on Schoology. Message me if you have any questions. Talk to you guys soon.